before this video starts, a quick reminder. In the description for every video that I've uploaded, there is a link to a form that you can fill out. This is the place to request videos on topics that you might want me to cover, as well as to review the video that you just came from. I am also accepting comments. In fact, I've already replied to a few. So if there's a question that you want to ask where you might want other people to know the answer to it as well, then you can ask it in a comment. But like I said, if you want to request a video, I would recommend that you do it in the form. But with that out of the way, this video is on differentiation and stationary points. This is a follow-up video to the previous differentiation video. If you don't know how to differentiate, this video will be of no use to you. But if you're confident in your ability to differentiate, then you can keep watching. So, we already know how to find the gradient at a certain point, but what else can we learn about a graph? Well, what if instead of finding the gradient at a certain point, we could find the point at which it has a certain gradient? I mean, we definitely could do that, but what does it tell us? Well, what if we find the points at which the gradient is 0? On this graph, that would be these points. Now, normally you would associate a gradient of 0 with a flat line, but that's not the case here. What's actually happening is that as the graph curves, the gradient changes. For example, here it goes from positive to negative. So there is a point at which the gradient is 0, which is called a stationary point, as it is neither increasing nor decreasing. There are two types of stationary points, minimums and maximums, which are self-explanatory. You can tell which is which by looking at them on a graph. But what if you don't have the graph? You could draw them, but there is a different way to tell which it'll be. The second differential. The second differential isn't that hard to understand. You just take your differential and differentiate it again. Once you have the x-coordinate of your stationary point, you can plug it into your second differential formula and it'll give you a number. But how exactly do we use this and what does it mean? Well, it'll either be positive or negative, and this will tell you which type of stationary point it is. But be careful. A negative number indicates a maximum point, while a positive number indicates a minimum point. And here is why. See, when you have a negative gradient, that means that the line is angled downwards, and a positive gradient angles the line upwards. So, a positive differential would make the gradient increase, and the line would go up. So, if the line goes from going down to going up, the rate of change of gradients must be positive, as the gradient is going from negative to positive. But just as the gradient and the differential reach 0, the line will be at its lowest point, and then it will go back up again, making it a minimum. The reverse will happen for maximum points. The graph will go from having a positive gradient to then having a negative gradient, which means that the change in gradient will overall be negative. But because the graph goes from going up to going down, then we end up with a peak. And that's actually all I have to say on the second differential and stationary points. There was enough here to warrant making it a second video instead of including it in the differential video, which was already quite long. So I separated the two out. If there's anything from this video or the previous one that you still don't understand, or you feel like I've missed something out, then feel free to let me know, either in the survey or in the comments. But other than that, that's all I've got to say.